Welcome to your comprehensive guide for AWS interview preparation. Amazon Web Services has become the leading cloud platform, powering millions of applications worldwide. Today's session covers the essential services that appear in virtually every AWS interview. You'll learn about Elastic Compute Cloud, or EC2 for virtual servers, Simple Storage Service, or S3 for object storage, Lambda for serverless computing, Relational Database Service, or RDS for managed databases, along with deployment strategies and cloud architecture best practices. These topics form the foundation of cloud computing knowledge that interviewers expect candidates to master. Elastic Compute Cloud, commonly known as EC2, is Amazon's virtual computing service that provides resizable compute capacity in the cloud. At its core, EC2 offers virtual computing environments called instances. Key components include AMI, or Amazon Machine Images, which serve as templates for your instances, key pairs for secure authentication using public and private keys, security groups that act as virtual firewalls controlling inbound and outbound traffic, and storage options including Instant Store for temporary storage and Elastic Block Store, or EBS for persistent storage. During interviews, focus on understanding instance lifecycle management, how a MI selection impacts performance, VPC and subnet configuration for network isolation, and the various pricing models including on-demand, reserved, and spot instances. AWS offers different instance families optimized for specific workloads. General-purpose instances like T3 and M5 provide balanced CPU, memory, and networking resources, making them ideal for web servers, small databases, and development environments. Compute-optimized instances, such as C5, deliver high-performance processors, perfect for CPU-intensive applications like scientific computing and high-performance web servers. Memory-optimized instances, including R5 and X1, offer large amounts of memory for in-memory databases, real-time big data analytics, and high-performance databases. Storage-optimized instances, like i3, provide high sequential read and write access to large datasets, suitable for NoSQL databases and distributed file systems. The key interview principle is selecting instance types based on your workload requirements across 4 dimensions: CPU power, memory capacity, storage performance, and network throughput. Simple Storage Service, or S3, offers multiple storage classes designed for different access patterns and cost requirements. Standard Storage class provides low latency and high throughput for frequently accessed data with 11 nines durability. Standard Infrequent Access, or IA, offers lower storage costs for data accessed less frequently, but requires rapid access when needed. One zone IA stores data in a single availability zone, providing 20% cost savings compared to standard IA, but with reduced resilience. Intelligent tiering automatically moves data between access tiers based on changing access patterns without performance impact or operational overhead. Glacier provides secure, durable, and low-cost storage for data archiving with retrieval times from minutes to hours. Deep Archive offers the lowest cost storage for long-term retention with 12-hour retrieval times. Key S3 features for interviews include versioning for object history, cross-region replication for disaster recovery, lifecycle policies for automated transitions, and event notifications for triggering workflows. S3 security operates through multiple layers of access control. Bucket policies and object policies use JSON-based access policy language to grant or deny permissions to S3 resources. Access control lists, or a CLS, provide legacy access control at bucket and object levels. Server-side encryption protects data at rest using AWS managed keys, customer managed keys, or customer-provided keys. AWS CloudTrail integration provides detailed logging of all S3 API calls for security auditing. Access methods include pre-signed URLs for temporary access to private objects, static website hosting for serving web content directly from S3, CloudFront distribution for global content delivery with caching, and cross-origin resource sharing or CORS configuration for web applications. The example policy shown demonstrates allowing public read access to objects in a specific bucket, which is commonly used for static website hosting scenarios. AWS Lambda is an event-driven compute service that runs your code without provisioning or managing servers. Lambda functions are stateless and have a maximum execution time of 15 minutes, making them perfect for short-running tasks. The service supports multiple programming runtimes including Python, Node, JS, Java, C#, and Go. Lambda automatically scales to handle concurrent executions based on incoming requests. Key characteristics include pay-per execution pricing, where you only pay for compute time consumed, automatic scaling without capacity planning, and built-in fault tolerance across multiple availability zones. Common event sources that trigger Lambda functions include a PI gateway for HTTP requests, S3 bucket notifications for file uploads, DynamoDB streams for database changes, and CloudWatch scheduled events for cron-like functionality. Lambda fits perfectly into serverless architectures, where you focus on code rather than infrastructure management. Lambda excels in several common use cases. Image and video processing workflows automatically resize or convert media files when uploaded to S3. Real-time file processing handles log analysis, data validation, or format conversion as files arrive. ETL or extract transform load operations process data between different systems on demand. API backend services create serverless web applications using API gateway and Lambda. Event-driven applications respond to changes in other AWS services immediately. Best practices for Lambda include minimizing cold start time by keeping functions small and avoiding heavy initialization, reusing connections and objects outside the handler function, using environment variables for configuration instead of hard-coding values, monitoring performance and errors with CloudWatch metrics and logs, and optimizing memory allocation since CPU power scales with memory. The code example demonstrates a typical Lambda function processing S3 events, extracting bucket and object information from the event payload for further processing. Relational Database Service, or RDS, is AWS's managed database service that handles routine database tasks like automated backups, software patching, monitoring, and hardware provisioning. RDS supports 6 popular database engines. PostgreSQL offers advanced SQL features, JSON support, and complex query capabilities, making it ideal for applications requiring sophisticated database operations. MySQL provides fast performance, wide compatibility, and cost-effective solutions for web applications. SQL Server delivers enterprise-grade features, seamless, net integration, and advanced analytics capabilities for Microsoft-centric environments. Oracle provides enterprise-grade reliability, high availability features, and advanced security for mission-critical applications. Aurora is AWS's cloud-native database that's 5 times faster than MySQL and 3 times faster than PostgreSQL, with auto-scaling storage that grows automatically. MariaDB offers MySQL compatibility while being open source with enhanced features and better performance optimizations. RDS offers 2 distinct scaling and availability solutions. Multi-AZ deployment focuses on high availability and disaster recovery by maintaining a synchronous standby replica in a different availability zone. When the primary database fails, RDS automatically performs failover to the standby instance without manual intervention. Multi-AZ provides no performance benefits since the standby replica doesn't serve read traffic, uses the same endpoint URL so applications don't need changes, and includes maintenance window benefits where updates happen on the standby first. Read replicas focus on read scaling performance by creating synchronous copies of your database that can serve read-only queries. Read replicas support cross-region deployment for global applications, use separate endpoints requiring application modifications, and are perfect for analytics and reporting workloads. Key interview distinctions. Multi-AZ is for disaster recovery with automatic failover and same availability zone billing, while read replicas are for performance scaling with manual promotion to primary, cross-region support, and read-only access limitations. AWS supports 4 primary deployment strategies, each with distinct advantages and trade-offs. Blue-green deployment maintains 2 identical production environments where you switch traffic instantly between the current blue environment and the new green environment. This approach provides zero downtime and quick rollback capabilities, but requires double the resources and higher costs. Rolling deployment gradually replaces instances with the new version, updating a subset at a time while maintaining service availability. This strategy is cost-effective and allows gradual rollout, but takes longer to complete and temporarily runs mixed versions. Canary deployment routes a small percentage of traffic to the new version for real-world testing before full rollout. This approach provides excellent risk mitigation and real user feedback, but requires complex monitoring and slower rollout processes. Recreate deployment terminates the old version completely before deploying the new version. While simple and providing a clean state, this strategy requires downtime and impacts users. AWS provides deployment services including CodeDeploy for automated deployments, Elastic Beanstalk for application platform management, ECS and EKS for containerized applications, CloudFormation for infrastructure as code, and Systems Manager for patch management. Modern cloud applications follow established architecture patterns that provide scalability, reliability, and maintainability. 3-tier architecture separates applications into presentation, application, and data layers, providing clear separation of concerns, independent scalability of each tier, and easier maintenance through modular design. Microservices architecture breaks applications into small, independent services that communicate via PIS, enabling independent deployment cycles, technology diversity across services, and fault isolation where one service failure doesn't bring down the entire system. Event-driven architecture enables components to communicate through events rather than direct calls, providing loose coupling between services, real-time processing capabilities, and horizontal scalability based on event volume. Serverless architecture uses functions-as-a-service models with automatic scaling and pay-per-execution pricing, eliminating server management overhead while providing automatic scaling and cost efficiency. The AWS Well-Architected Framework defines 6 pillars for designing robust cloud systems: security for protecting data and systems, reliability for system recovery and availability, performance efficiency for optimal resource usage, cost optimization for achieving business value, operational excellence for running and monitoring systems, and sustainability for minimizing environmental impact. Security best practices form the foundation of any AWS deployment. Always use IAM roles instead of access keys for applications, as roles provide temporary credentials that automatically rotate. Enable encryption for data at rest and in transit using AWS-managed encryption services. Conduct regular security audits using AWS Config and Security Hub to identify misconfigurations. Monitor all API activity with CloudTrail for security analysis and compliance. Follow the principle of least privilege by granting only the minimum permissions necessary for users and applications. Cost optimization strategies significantly impact your AWS bill. Right-size EC2 instances by monitoring CPU, memory, and network utilization to match instance types with actual workload requirements. Implement S3 lifecycle policies to automatically transition data to cheaper storage classes based on access patterns. Use reserved instances for predictable workloads and spot instances for fault-tolerant applications to achieve up to 90% cost savings. Configure auto-scaling groups to automatically adjust capacity based on demand, avoiding over-provisioning. Regularly monitor costs using AWS Cost Explorer to identify optimization opportunities and set up billing alerts to prevent unexpected charges. Success in AWS interviews requires focusing on practical scenarios, understanding how services integrate together, and being able to explain trade-offs between different architectural decisions.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.